Alright, this is going to be 6.5, Algebra Properties. It starts on page 473. And these are what your pages should look for, so make sure you're opened up to those. Take some notes. Alright, the first example says Real World Link. Angelica and Nari are baking cookies for a bake sale fundraiser. Angelica baked 6 sheets with 10 cookies each, and Nari baked 10 sheets with 6 cookies each. So you need to figure out how many total cookies Angelica baked, Nari baked, and then what do you notice about those. So go ahead and solve those, and when you come back, I'll have the answers. Pause now. Alright, so here are the answers. You should have filled in multiplication for both 1 and 2, and that the answer would be 60 cookies. So basically, Angelica used less baking sheets, but put more cookies on the sheets. And Nari used more baking sheets and put less on each sheet. But they came out with the same 60 cookies each. Number 3, they're the same. And what we should have learned was that, or what we should have seen was that the order in multiplication doesn't matter. Okay, that's a commutative property of multiplication. So, commutative property of multiplication. So, commutative property of multiplication says that order doesn't matter. So, use properties to compare expressions. Commutative properties, the order in which two numbers are added or multiplied does not change their sum or product. So, if you have 7 plus 9 and 9 plus 7, they both equal 16. If you have 4 times 6 and 6 times 4, they both equal 24, so they're the same. And so they've showed you the algebraic way as well, where A plus B is the same as B plus A, and A times B is the same as B times A. So just using the algebraic expressions to say the same exact thing. Associative property, remember associative property says the way in which 3 numbers are grouped when they are added or multiplied does not change the sum or product. So if it's all multiplication or it's all addition, you can switch up the order and it won't change your final result. So if you wanted to add 3 and 9 first and then add 4, that's fine. Or if you want to add 4 and 9 first and then add 3, that's fine. Same with multiplication. You can multiply 7 times 5 first and then times the 8, or you can do 8 times 5 first and then times the 7. So it's completely up to you. It's all about your mental math and what makes more sense. With a problem like this one, with 8 times 5 times 7, I would do 8 times 5 first because that's a nice round number, 40. And then I can do 40 times 7, and that's 280. And I can do that mental math because of the way that I made it work. If I had 35 times 8, I don't have mental math to do that very quickly. So, it's just the way to do it. Now, identity properties, the sum of an addend and 0 is the addend, and the product of a factor and 1 is the factor. So if you have 13 plus nothing, you still have 13. If you have 7 times 1, you still have 7. So if you have A plus 0, it's just A. If you have A times 1, it's just A. Alright, so properties are statements that are true for any number, and the expressions 6 times 10 and 10 times 6 are called equivalent expressions, and that's what this whole section's about. Because they have the same value, they're called equivalent expressions. This illustrates the commutative property, that 6 times 10 is the same as 10 times 6. So equivalent expressions. Alright, so example number 1 on the next page says determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. So we've got 15 plus, in parentheses, 5 plus 8, and then 15 plus 5 in parentheses plus 8. So if we do this, we've got 13 plus 15, which will equal 28. And this one will get 20. 20 plus 8 will be 28. So, in fact, they're both the same. The difference here was that they moved the parentheses. They didn't change the order. It's still 15, 5, and 8. That's the order that it was in. So it's not commutative property because they didn't change the order. They did change the groupings, and that's what associative property is all about. So the answer is they are equivalent by associative property. And that's exactly what the answer should say for you. They are equivalent by associative property. Example number 2 has 20 minus 12 in parentheses, then minus 3, and then they have 20 minus, and then 12 minus 3 in parentheses. Now, just looking at this, you should be able to tell whether or not this is going to be equivalent or not. Because you should know your properties by now, and does subtraction apply to either commutative or associative properties? No. The answer is no. So automatically I know that this should not be equivalent because commutative and associative properties don't work with subtraction. But I'm going to go ahead and solve it out because I know how to solve. 20 minus 12 is 8 and 8 minus 3 is 5. And then on the other side I would need to do 12 minus 3 first, which is 9. And then 20 minus 9. Oh, I can't get my 0 to come on here. 20 minus 9 is 11. Good job. Jackson's a fool. All right, nobody heard that. All right, so 5 and 11 are obviously not equal, so this is not going to work. And the reason is that the expressions are not equivalent because associative property is not true for subtraction. So the expressions are not equivalent because associative property is not true for subtraction. Alright, now example number 3, it says determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. So 34 plus 0 and 34. We should see that 34 plus 0 is 34 and 34 is 34, so they are equivalent, so that's my check mark. So the expressions are equivalent, and we just talked about that adding 0 or multiplying by 1 is called the identity property because it doesn't change the identity of the numbers at all. If you add 0 to it, it doesn't change. If you multiply it times 1, it doesn't change. So that's called our identity property. So the expressions are equivalent. So now you need to do A and B on your own, and when you come back, we'll have the answers. So pause now. Alright, so for A, the answers are 90 and 90, so they are equivalent, and that is because of associative property. The order didn't change, it's still 5, 6, 3, 5, 6, 3, but the grouping did. They put 6 and 3 in parentheses at first, and then 5 and 6 in parentheses on the second part. In the end, it came out to be the same answer because associative property of multiplication says that you can change the groupings and your answer will stay the same. For B, it is not equivalent because commutative property does not work on division. If you notice, they changed the order. It was 27 and 3, and then it became 3 and 27, and so they changed the order. Commutative property is not going to work on division. It doesn't apply to a division problem. All right, so here's a little note that they put on the book. It says that the commutative property does not hold for division. To prove this, simplify the expression in example 4. So they had 20 divided by 5, which is 4, and 5 divided by 20, which is 1/4. So since 4 is not equal to 1/4, expressions are not equivalent. Alright, so I'm not going to go over example number 4. This really sums it up. It's not going to work. It would be 20 divided by 5 is 4, 5 divided by 20 is 1/4, and since that's not equal, the expression is not equivalent. And the reason why is because commutative property does not hold for division. So it's not equivalent. So use properties to solve problems. Properties can be used to write equivalent expressions and to solve problems. In number 5 it says, in a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Write 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. And that means we're talking about the associative property. You've got 15 plus 4 forwards plus 3 centers. And you could either put together 15 and 4, or you can put together 4 and 3. So go ahead and solve for C. Brandy earned $7 babysitting and $12 cleaning out the garage. Write 2 equivalent expressions using the commutative property that can be used to find the total that she earned. So write with commutative, using commutative property, I want you to write two equivalent expressions to represent $7 babysitting and $12 cleaning the garage. Pause. Alright, so you can write that either as $7 plus $12 or $12 plus $7. Either way, she's going to earn $19. So it comes out the same. Alright, example number 6 says that the area of the triangle can be found using the expression 1/2 times base times height, where b is the base and h is the height. Find the area of the triangle shown to the left. So the way that I'd have you always set up is by writing out the expression, the formula, okay? 1/2 times base times height. Everybody should be writing this. Then you're going to fill in the base. The base is usually the bottom. So we're going to do 1/2 times 15 times, and then the height is 12. Here's the thing. If I leave it like this, I'm going to have to find 1/2 of 15. That would be my first step, because I would work from left to right. But obviously finding 1/2 of 15 isn't going to be an even number. Wouldn't you rather find 1/2 of 12? Because 1/2 of 12 is an easy number, right?
Yes.
Alright,
Yes, it is.
so I'm going to change my order here, and I'm going to say, okay, how about we do 1/2 times 12 times 15. And so I can do my 1/2 times 12 first, which would be 6. And then 6 times 15, which is 90. So the area of the triangle here is 90 square feet. Okay, because don't forget your units. So this is just an example of where we would apply it just to make math easier. Why would we want to do 1/2 times 15 when we can do 1/2 of 12 very quickly? If we had 1/2 15, we're going to still have a fraction. Whereas if we do 1/2 times 12, we have a whole number, and we have whole number times whole number, which is super easy. Alright, now you're going to do D. Vicki earned $6 an hour while working 11 hours over the weekend. She put 1/3 of what she earned into a savings account. Find out how much she put into the savings account. So you need to write the expression and solve it. So how are you going to figure out that Vicki earned $6 an hour while working 11 hours over the weekend, and that she put 1/3 of that into her savings account? We want to know how much she put into the savings account. Pause the video now and find the answer, and come back and I'll have it for you. That singing was brought to you by Taylor Pryor and Mialyn Santos. Thank you. Alright, now there's several different ways that you can set up this equation. You can do 6 times 11 times 1/3. Solve the 6 times 11 first and say, okay, 66 times 1/3. Cross simplify by dividing by 3, and you would get 22. So $22 into savings. Or you could write the equation like Dakota did in first period, where he said 1/3 times 6 times 11, and he took care of the 1/3 times 6 right away, because you can cross simplify there and get 2, and then 2 times 11 is $22. So either way, she's got $22 that she put in her account. Those were both equivalent, that you could do 6 times 11 times 1/3, doing 6 times 11 first, or you could do 1/3 times 6 first times 11. So it's completely up to you which order you'd like to do this in. Alright, that ends our Chapter 6, Lesson 5, Algebra Property. Does anybody want to sing us out?
Me.
Please. Please go on. First period, sing us out. Alright. I think that was High School Musical 3, right?